right, guys, so here's our review for our test. Okay. Our first picture here, we are going to find a path, we're going to find a circuit, vertices and multiple edges, a loop, a bridge, adjacent edges, and adjacent vertices. And keep in mind, there's more than one right answer here. A path, just make sure it starts somewhere and ends somewhere differently. That's a path. A, B, C, D. That's a path. Whereas a circuit is A, B, C, D, A. The key is I never lift my pencil on a path. I never lift my pencil on a circuit. But a circuit returns to the original vertice. A vertice with multiple edges would be something like H and G. Okay? Because H and G have two different lines that connect it. A loop, we always name with two letters. And it's the line that leaves a vertice and returns to it. The bridge would be DE. If I eliminated my line here, I'd have two separate graphs. Adjacent edges are edges that share a vertice. So HE would be adjacent, HE and FE would be adjacent edges. Edges that share a vertice, they share E. And adjacent vertices are vertices that share an edge. I'd say G and F would be adjacent vertices. They share one edge. So those are our basic definitions. Now, on the test, I'm going to ask you to find the circuit, the path, or neither. So on all of these pictures, the first thing I'm going to do is I'm going to get the degree of each vertex. And I'm going to write it right next to it. And if you notice here, this picture literally has no odd vertices, which means it can be a circuit. So I'm going to start at A. I'm going to go up. I'm going to go over. I'm going to come around. I'm going to go down. I'm going to go over. And if you notice, I'm just trying to take care of sections of the graph. Going down, left, up, left, down, over, and I always want to give myself a path back. Okay? Now, you didn't have to go that way. All right? But start doing something, and the path or the circuit in this case will make itself available to you. And I'm going to write circuit as my answer. My next one, 2. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. 1, 2, 3. 1, 2, 3, 4. Okay. Here I have two odd vertices, which means I have to start at one and end at the other. So this is a path. All right, and just start taking care of parts of this picture. Right down, up. Okay, I got to go all the way down here. Okay, so I'm going to come back up this way. Over, left, down. I got to go all the way down this way, and I can come up, and I can come over. I go down, left, and now I'm back to my other odd vertice. And if you notice, every single line has an arrow on it. Right here, 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 right here. Every line has to have an arrow on it. Don't spend time trying to figure it out ahead of time. Just start moving around, and once again, the picture should make itself apparent. Now here, we have 3, 3, 4, 2, 4, 3, 3, 5, 4, 3. 3. How many odd vertices? 1, 2, 3, 4, 5, 6, 7. Oh, and I forgot this one. 8. So this is neither an Euler's path or Euler's circuit. But if I wanted to convert it to such, all I would do is connect the odd vertices. Here, here, and maybe right through here. And now, if I wanted to draw a path, I start at one odd vertex and I end at another one. So I'm going to start here, go around, over, back, down, over, down, left, up, down this line, down, over, keep going straight, so now I can take care of this area of my picture, up, going this way, down, come across this line right here, over, or I'm sorry, down and then to the left. And therefore every single line is accounted for. Okay. And now for this one here, oops. Okay, sorry, we have one more picture we can go over. 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 3, 3, 3, and 3. So if you notice here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Every vertex is odd. All right, so probably what I would do here is I want to turn this into a circuit. I'm going to connect every odd vertex. And now I should be able to start at A and return to A. To the left. Over and back. Down. Over and back. Right. Up and back. Over. Left and back. Okay. Now I'm going to come through here. Up. We're going to go down and we're going to go through our star. Down. Right. Over, down, and then up here, and then I can get back to my original point. So that's how I can convert pictures that are not Euler's path or circuits originally into an Euler's path or circuit. And then finally our groups. Mike is taking history, English, and driver's ed. History, English, driver's ed. They all need to be connected. Joe is driver's ed and video. So driver's ed to video. Tim is geometry, physical education, and calculus. Geometry, phys ed, and calculus. All three need to be connected. English and Spanish for John. So English and Spanish. Calculus and Spanish. So calculus and Spanish. Biology, English, and driver's ed. So biology goes to E, which is English, goes to driver's ed, and the driver's ed also has to go to English, but it already does. Biology and calculus, so we connect those two. Video and driver's ed, we already have them connected. And phys ed and Spanish and calculus. So phys ed goes to Spanish, phys ed already goes to calculus, and calculus has already gone to Spanish. So I'll start with geometry for group 1. G and B can be in a group. G and B. H can be in a group with G and also with B. E can't be in a group with B, so that's no good. S can be in a group with G, can be in a group with B, can be in a group with H. That one's good. V can be in a group with G, can be in a group with B, can be in a group with H, can be in a group with S. So V is good. C can't be in a group with G, and B can't be in a group with D, so don't worry about that. Group 2. P can go with E. P can't go with C. P can go with D. goes with E. E can't go with D, so D can't be in group 2. But in group 3, we can certainly put driver's ed and calculus together. So here's how we can do it, where we literally just have 3 groups. All right, guys, that is your test. Best of luck with it.